As this is a bit more hands-on module, let's go over the concepts and start with the SQL basics. SQL or SQL stands for Structured Query Language, and it is a domain-specific language to manage data. And did you know that the first version of SQL stems from 1974, which makes it a pretty old and widely used language. And with it you can perform create, read, update as well as delete functions. SQL is designed for relational databases, where data is modeled by relations, often in tables. The language itself, SQL, is an American National Standards Institute as well as International Organization for Standards standard. However, the implementations of the standard differ per vendor. So even though it is a standard, not all vendors properly implement the standard. This makes interoperability between different database vendors difficult. Some vendors even implement the possibility to perform system commands using the SQL language. So even if that's not a part of the standard, often you can do a whole lot of damage using SQL commands. A database is a format for data storage, and you have different patterns and structures on how that data is stored. This can be, for instance, a flat file, but often it is stored hierarchical and structured. And with hierarchical we mean like a parent-child relationship, a tree. A relational database stores its data in tables, and that's where you use SQL on, relational databases. And a schema describes the structure of a relational database. Besides relational databases, you also have other types, like for instance an object database. In the past years, another type of database became very popular, and that's the NoSQL database. This is a non-relational database type. However, No stands for not only SQL, and this is something important to keep in mind. NoSQL database types can also be vulnerable for injection. So if you have that question on the exam, remember this: NoSQL database types are still vulnerable. Let's briefly go over a SQL statement. Here you see a SQL statement: select name, email from the table users, where username equals Fred and password equals secret. And if you read it from left to right, first it says select the value of the name and email column from the users table, where it is a Boolean comparison, the username equals Fred and the password equals secret. So the SQL statement returns a row containing a name and an email address if there's a user having username Fred and the password being secret. You speak of SQL injection when you're able to inject code into the SQL statement itself. In other words, you control the query itself. And using SQL injection, you can retrieve or manipulate data. You can also manipulate control statements, like the statement we just saw, where a password is being compared to a password that the user entered. Using SQL injection, you can also influence the availability of data or even the whole database itself. And depending on the vendor or the specific flavor of SQL, so to speak, sometimes you can even perform remote code execution. So the impact of SQL injection attacks is huge. In practice, what does it look like, a SQL injection attack? Well, as stated before, the exact syntax depends on the underlying database. So there is not one size fits all SQL injection attack. It depends on the flavor that you're trying to attack. However, there are a number of delimiters, or characters so to speak, that you can always try to use because they're supported by the standard SQL version. Often you try to use the character delimiter or the single quote. The idea behind it is that you try to break out of the SQL statement itself, for instance when a string or character comparison has been done, and try to manipulate the SQL statement. You're trying to inject your own SQL command. Sometimes you try to use the string delimiter or the double quote. Another command that's often being used in SQL injection attacks are the single-line comment delimiters or two dashes. Effectively, this means that everything at the right side of the delimiter will be dropped, as it will be seen as a comment and not part of the original SQL statement anymore. And another character very important for SQL injection attacks is the query delimiter. This character allows you to piggyback or stack multiple SQL statements into one line. Each query is delimited by the character. So let's take another look at the SQL statement that we saw before. As stated, in this SQL statement, we select the value of the name and email column from the users table, where the username and password are known or are given. How can we manipulate the SQL statement in such a way that we still can retrieve the name and email from the users table without knowing the password? The only thing we need to know is the username. As an attacker, instead of using a normal password, let's fill into the password field double quotes and a Boolean statement or 1 equals 1. And we finish it off with two dashes. In other words, the right side of the SQL statement can be dropped. So if this would be in the value of the password field, then the SQL statement would read like the following. Select name email from users, where username is Fred and the password is empty, or 1 equals 1, which is always the case, and drop the rest of the statement. The payload is entered in the password field because the SQL statement doesn't properly filter out malicious control characters. Now the SQL statement becomes: select the value of the name and email columns from the users table. So far the same as the previous example. However, the only thing now that needs to be true is that the username equals Fred. And the attacker doesn't need to know the password in order to retrieve the name and email. This is an example of a SQL injection attack where the payload is double quotes or 1 equals 1. In the next clip, let's take a look at all the different types of SQL injection that exist.